alaikum wa rahmatullahi wa barakatuh. I am Loy Bashir from Group 5. Welcome everyone to our video presentation today. Discuss about COVID-19 in our subject Civil Engineering Mathematics 2. So everyone heard about this year. Discuss all the people about COVID-19, or all the people call it coronavirus. So what's coronavirus, and how Malaysia faced this problem? Okay, coronavirus or COVID-19. Coronavirus or COVID-19 pandemic is disease from series SARS. Also, the first case was in Wuhan, China, and in Malaysia, the government faced this disease by many decisions and effort. The Ministry of Health opened all hospital and all center of health to all people to recover all cases in Malaysia. So in this project, we are going to solve a problem by using first ordinary differential equation. Thank you everyone. I'm going to let my friend discuss about methodology.
I am Iyad Afif. I'm going to present about the methodology. In our studies, we have a certain population with a fixed number. That means we are ignoring the birth and immigration and so on. So this population is categorized into three groups. First group is the suspectables groups, or the healthy people who are not affected yet by the virus. The second group is the infectives, who already get affected by the virus and is carrying the virus and can be speeded up. The third one and the last group is the removed or released people due to the death or recovering from the virus. And now we need to understand the relationship between these three groups. So the virus attacked the suspectables, healthy people, and they moved them up to the infectives group, and with the time they removed from the infection group as they recover from the virus or they die. And now we come from the ODE equations. The rate of change in suspectables is equals to the suspectable at that time multiplying with the infected people times a factor, and the negative represent that the number is decreasing. The removed or released people individual, the rate of change equals to the infected people times a factor. And as we fix the population, so the total change is equals to 0. By substitute these three equations to each other, we can get the equation of the infected people, which equals to the factor times the suspectable times affected people at the same time minus factor times infection.
My name is Muhammad Abdurrahman Al-Maktari, matric number AF190276. Today I will present the part of calculation and discussion of the report, and I was told that I have limited time, so I will be quick. So the first thing in the calculation, I needed a real data from Malaysian, from the cases recorded by the Malaysian government between 18 March and 18 April. You can see the graphs for recovery and infected and deaths rate in the period of time from 18 March to 18 April. The second step is to convert it from a graph to Excel table to make it more manipulatable, so I can change the numbers and add them as I want to. RT represent the release, IT represent the active cases, IT new is just the new cases, and ST is the susceptible over the course of 13 days. We will only focus on the infected and recoveries in this project, and we will not discuss the susceptible because we only recorded 4,632 new cases in the whole month, and that's only 0.01% of the population, which is very small number, and we cannot draw a graph using it. So the focus will be on infected and recoveries. By referring to the equations in modeling, we can see B and K, which is the rate of transmission B and the rate of recovery K. To get the values of P and K from the table above, you can refer to some rules in the science of probabilities. So to get P, you have to consider the new cases for today over the number of active cases the day before to get the rate of transmission, how many people transmission the disease to the active case, the new cases next day. By the same logic, we got the K, which is the recovery rate, which is the number of recovery over the total of cases, which is the infected plus the recoveries. From those two equations, we got to add the values of K and B for our Excel sheet. Now we have all the variables we need. All we have left is to make the prediction. So we will use the data from the 20 days earlier to predict what's going to happen in the 10 days after that, and then compare our predictions to the real world data and see the difference and discuss the difference. So to take to make the equation for the prediction, we need to consider the value of P and K for the average for the first 20 days, and that's exactly what I did. B average for time from 1 to 20, and we got the value of B. Using the same logic, we got the value of K for this K average for the first 20 days, and after that we were able to get the number of released people and the number of infected people as a prediction, not real data. This one is prediction. As you can see, from the 20 days and below is the new data or the predicted data. We got to plot the tables like that. The blue line in the blue curve is the real data, and the red line is the prediction for released and infection.
It's me, Noor Atira Najwa. I will present about discussion regarding this project. From this project, as you can see, we have two figures. For figure 1, we have recovery cases, and for the figure 2, we have infected cases. Recovering cases. For recovering cases, we have two graphs, which the blue one represent for our real case data, meanwhile the orange one represent from our prediction data that we have come from our calculation. As you can see, our real case data has the higher compared to our prediction data. This is because in our procedure to get prediction data, we have a few limitations. For example, isolation bed, ICU bed, providing a mask, providing oxygen supply equipment, COVID hospital, and providing a mask and personal protective equipment. This factor can increase and influence our recovery case data in Malaysia. As for figure 2, we have uninfected cases data. The blue one represent for our real data, meanwhile the orange one represent for our prediction data that have come from our calculation. Okay. For as you can see, up to 20 days, the real case data and the prediction data have a same pattern of increasing, but after 20 days, the real case data has become decreased significantly. This create a big difference compared to our prediction data. It's because in our procedure to gain prediction data, our data is not limited to a few factors. For example, social distancing, travel limitation, isolated infection, hygiene and hand wash. This can influence our infected cases data in Malaysia. This showed that the MCO, which movement control order that have been practiced to us, have become a significant effect in our infected cases data of Malaysia. That's why our prediction data and our real case data is different.
Champakan Nurul Atira binti Surizam will tell you about simple conclusion. From the graph and the factors that my friend tell, we'll know that how the social distancing save us from spreading the virus and the effect when we neglecting it. So we must follow the government instruction to save our life and our country. Okay, thank you. Assalamualaikum.